Today we're going to look at linear inequalities. And really we're going to focus on graphing linear inequalities. So we'll get into some further stuff with this, like in the next units and stuff like that. But really we're going to concentrate on graphing these linear inequalities and kind of like the ins and outs of it. So let's go ahead and start. Let's get my marker ready to roll. All right. So we've got our notes tell us that a linear inequality is similar to a linear equation. It just has an inequality symbol. So that's true. So like y equals mx plus b, it'll just be with an inequality symbol in front. So you graph them the same exact way, other than a few contingencies, but we'll get into that. So first, let's just start off with kind of like a little warm up, or just making sure that you understand that sometimes ordered pairs may not work in a certain inequality. So in order for these points to satisfy this inequality, we need it to basically be true when we plug these 2 points in. So in an ordered pair, the first coordinate is x, second coordinate is y. So all that means is you just plug in x and y in this equation and solve it, or simplify it. So we've got 4 greater than or equal to, because 4 is y, so we plug that in for y. Negative 2, we plug in 7 for x, plus 9. Then we're just going to work that out. So 4, negative 2 times 7 will be negative 14. So negative 14 plus 9 would be a negative 5. So then we see 4 is greater than or equal to negative 5 because it's greater than 5. So that's a check. And what'd you say? Like, yes. So that satisfies that. And that's pretty much what you do for the other two. I'll let you do those examples, but that's what you pretty much do for the other two. You just plug them in. If it's true, then yes. If it's not true, then no. We're not going to really worry about this real world example right now. We'll do some of that stuff probably later on. Right now, we're just going to get the basics of graphing linear inequalities. So when graphing linear inequalities, it is a visual representation of ordered pairs that satisfy that inequality. So it's almost like when you graph this, it'll tell you pretty much where your answers will come from. All right, so we use slope-intercept form, and you have to be sure that when you put it in slope-intercept form, which is y equals mx plus b, that if you ever multiply or divide by a negative to do that, then your inequality symbol flips. So anytime you're dealing with inequalities, if you ever multiply or divide both sides by a negative number, you've got to flip it so that rule still remains. So when you graph the line, there's only a few things you've got to keep in mind. So initially, you have to figure out if you use a dotted line or a shade, or like a full line. You use dotted lines or dashed lines for just less than or greater than. So here's the way I remember it. It's the same way as kind of I told you to remember closed points and open points when we're doing graphs. So if I've got this here, if it's got that line under the inequality sign, then it tells me I use a straight line, or I use a full line. But if that line is not there, so if we just had that, that means I use a dotted line. So that's really pretty much the differences between those. And that's just stuff you've got to memorize. And then the last part is you have to either shade above it or below it. So you want to shave above the line if it's a greater than symbol, and you want to say shade below if it is a less than symbol. So let's do some examples. So when we're graphing these, we graph them just like we would graph a normal line. So y is less than 2 over 3x minus 1. So this 2 over 3 tells us what m is. So that's our slope. So our slope is 2 over 3, which is just rise over run, same as normal equations. And then this negative 1 tells me my y-intercept, or my starting point. So when I want to graph these two, or when I want to start my graph, I'm going to, let me see if I can zoom in on this a little bit to try to, okay, there we go. So when I'm graphing these two, I'm going to start at negative 1. So I'm going to go down here to negative 1. And then I'm going to go up 1, 2. So up 1, 2. Now I'm going to go over 1, 2, 3. So That's where my point would be. And now I need to decide before I ever create my line, do I need a dotted line or do I need just a normal filled in line? This inequality symbol does not have a line under it, so I'm going to use a dotted line. So it'll kind of look like this. It'll be like a dashed line. And you put arrows onto that. So if you were just looking at that graph, that would tell you that this was an inequality, and it was a inequality that was not included. It was not like less than or equal to or greater than or equal to. It was just greater than or less than. And then the final step is our shading step. This will tell us where our answers come from that satisfy this equation or this inequality. And we find that from this symbol as well. If it's greater than, we would shade above this. If it's less than, we shade below it. And it is less than, so we just shade below that line. And that's what that graph would look like. So we'll do number 2. Number 2 is a greater than, and it's got a line under the inequality symbol. So this will be completely different. So first of all, we know that we have to find our slope and we have to find our starting point or our y-intercept. So first of all, our slope would be -4. And then this is like plus 0, so we're going to start at the y-intercept of 0. Okay? So that's where we can go ahead and create our 2 points. That's what I would do. I would create your 2 points first. So we're going to start at 0. And then we're going to go down 4 and over to the right 1. So down 1, 2, 3, 4, over to the right 1. So these are our 2 points that we'll be connecting. We have to determine when we create our line if it's a full line or a dashed line. This inequality symbol has a line under it, so that's going to be a full line. So we can just draw a line through both of these. Let me try to draw it straight. Okay. Now we have to decide if we want to shade it in greater than or less than that line. And I know that it's kind of odd to look at this line and determine whether you would go above or below, but if you notice, all the line numbers over here would be less than the numbers that are over there. So that's kind of an indicator of what above and below means. So in this case, it's greater than, which means we're going to go above it. So that would be everything to the right of it. And that would be above that line. And then you may have some examples where you have to manipulate the equation to get it in slope-intercept form. But I'm going to let you guys do that. And we'll also work some examples in class. But that's just the basics of graphing linear equations.